Question number 35. Three resistors R1, R2 and R3 are connected in parallel to a cell. Okay, so all this has been given. Which equation can be obtained by applying Kirchhoff's second law to the voltage? What is Kirchhoff's second law to the voltage? Like second law to circuit, which is nothing but KVL. KVL tells you that sum of the IR drops plus voltages is equal to 0 in a closed loop. So how do we do it now? Now you see, let me draw some values over here. A, B, C, D, E, F, G and H. Okay, you don't want to analyze anything, you can directly say here, there's nothing but one of the loops is I equal to I1 plus I2 plus I3. Okay, but that is your KCL, but he wants KVL over here. Okay, so definitely anything related to current is incorrect. Okay, and then the second one you can say is that you can say V0 should be equal to V1 equal to V2 equal to V3. That is not KVL actually. That is nothing but you derive this rule by saying that the resistors are seen to be parallel to each other. So based on this you can say this law is correct and this is incorrect, because you know only in series is correct. So you can directly say this is the correct answer. But if you want to look at the KVL and then do it, then what you do is take up the first loop. I am explaining you the KVL part of it. Now if I take the closed loop like A, B, G, H, now what do you see here? The current passes like this. This is the voltage over here. So if this is your V0, I can now write for this one A, B, G, H, A, I can now write V0 is equal to V1, right? And if I look at this one, the second one, A, C, F, H, A, C, F, H, A. If I look at this, A, C, F, H, A, then you see this is your F0, this is your V2. So I can now write V0 is equal to V2. Then if you look at the third loop over here, which is this, A, D, E, H, A. A, D, E, H, A. If you look at this loop, then what do you see? V0 is equal to V3. V0 equal to V3. Combining all this, you can say V0 equal to V1 equal to V2 equal to V3, so which is nothing but COV. Okay.